Question 1. 3.5 liter of Na2 gas at 80.6 degree Fahrenheit is held in a piston with a constant pressure. If the temperature is raised to 620.6 degree Fahrenheit, what would the final volume would be? We will see our given. So our given, if V1 or V initial would be 3.5, temperature 1, 80.6 degree Fahrenheit. We are looking for V2, and temperature 2 is 620.6 degree Fahrenheit. Now we have to convert our degree Fahrenheit to Kelvin. So first, to convert degree Fahrenheit to Kelvin, we have to convert degree Fahrenheit to degree Celsius. To do that, we will subtract 32 and multiply it by 5/9, and we'll get 27 degrees Celsius. So 27 degrees Celsius plus 273.15, that would be 300.15 Kelvin. That would be our temperature 1. Temperature 2 would be 620.6 minus 32 times 5/9. That would be 327 degrees Celsius. To convert that to Kelvin, it would be 327 plus 273.15, and our temperature 2 is gonna be 600.15 Kelvin. Now we have the Charles law right here. We just have to cross multiply and find V2. Then we just have to insert our 3.5 number and our T2, 600.15, and divided by T1, that's 300.15 Kelvin. We can cancel out Kelvin by Kelvin, and we will get 6.99 liter for our volume 2, and we can round it to 7. Thank you, that's all.